So welcome to our second general body meeting. For those of you who don't know me, I'm Alex. I'm the ACM UC president. I will be your entertainment for this evening. Just a heads up, you're being recorded. We record all our meetings. Slides and videos will be available post-meeting at acmuc.org/archive. So go check those out if you ever miss a meeting and you want to see what we did. Fill out the attendance at acmuc.org/c. This is how we determine voting rights and membership, so make sure you sign up if you're here. So for those of you who don't know, what is ACM? Well, we're a group of students built around a common interest in computers. We host workshops, hackathons, other things, and all majors are welcome. But I won't say on that anymore because I assume you know who we are. We follow a code of conduct, which you can find on our website at that link. We also follow the UC code of conduct, so anything that applies at a UC event also applies here. A couple things about our services. We have academic services, programming review sessions, office hours. You can see up there, so feel free to take advantage of those. The International Collegiate Programming Contest is this fall. It's coming up again. UC typically hosts the regional competition for this, so if you're interested, stay tuned. You can talk to either me or Professor John Franco about if you're interested in volunteering to help the event or joining a team to compete. The registration info will be sent out in our Slack and via email once we have all the details figured out. Also, resume review. Christian, you want to talk about that?
Sure. So we're going to be hosting a resume review, technically independently from ACM, on September 23rd. That's this coming Monday. If you want to sign up, there's a message in Slack as well as an email sent out today. I believe we have just under half of our spots remaining right now, so if you want to sign up, get in there quick. And yeah, that's it. Come to me if you have any questions about it.
Yep, we've also got details in the Slack, so you can check them out. Revolution UC. If you haven't seen our new branding, this is the new colors for Revolution UC. I'm glad you're excited.
Let's go.
So Revolution UC is probably the biggest event that ACM puts on. It's our 24-hour hackathon that's hosted every spring. 24 hours of free food, coding, learning, fun, and chances to get prizes and connect with sponsors. Go to revolutionuc.com for any updates, and they will be posted there as they appear. In the meantime, Make UC, which is our more relaxed 12-hour version of Revolution UC that we host alongside IEEE, that's this weekend. So sign-ups are still open at makeuc.io. If you are interested in showing up for 12 hours, networking with some of our sponsors, which you can see up at the top there, and working on some cool projects, definitely show up. Some notable things about this that are different from Revolution UC, aside from the fact that it's 12 hours, it's also non-competitive, so you can work on projects that you have already started. So that's an interesting thing. We'll be raffling off prizes to people who demo, so it's not a competitive prize, but you can still have opportunities to walk away with something. Also, you get free food the whole time, so that's pretty cool. If you have any questions, you can contact me, and I will be happy to answer. Slack is the best way to get connected with us. Go ahead and sign up at our acmcincy.slack.com/signup and introduce yourself. It's a great way to be connected and a part of this community. And that brings us to our talk for today. So I want you to all give a warm round of applause for your speaker, me. So today I'm going to tell you a little bit about both the command line and Git. And so these are some really important, really prevalent tools that any software developer should know. So I'll give you just an introduction to them, and sort of we'll have some people here. If you guys want to raise your hands a little bit. Yeah. Okay. Well, these guys up front here are going to help you. If you have any questions, just raise your hand, and somebody who knows what they're doing will come and talk to you. Also, I can answer questions. Okay, so let's start with, I'll skip what is a computer, because I think you know that one. But let's start with what is a command line? A command line is a text-based interface for a computer, right? It's more flexible and easier to program than a GUI, which is why we still have it around. And today we're going to learn a little bit about the Unix-style command line. So, if you guys have a Mac computer or a computer that's running Linux, congratulations, you guys have a Unix-like operating system, which is just an operating system that is descended from Unix. If you have Windows, I'm sorry, you don't have a Unix operating system. And so we're going to have to install all of the stuff here if you don't have Git or package managers. So for Mac OS, it does not come with a package manager to start. You'll probably want to install Homebrew, which you can find at brew.sh, and that has instructions to install. It's pretty simple. And once you've done that, you can install using the command brew install Git, and that'll install Git for you. For Linux or any sort of version, use your package manager. If you're using Ubuntu, that'll be apt. So you want to say apt install Git, and you'll probably need to run that as sudo for permissions. For Windows users, which is probably a lot of people here, you can download Git Bash from gitforwindows.org, and that will give you a Unix-style command line, and it will also give you Git pre-installed with it. So feel free to follow along. I'm going to give a second for people to do that if they want. Raise your hand if you have any questions or problems. So while that's downloading, I'm going to talk a little bit about what is version control. So version control, commonly called VCS or version control system, keeps track of code changes. It's a way to manage your code base. It's also really useful for collaboration with others on the same code base, and it provides transparency so that people can see the code history, they can see what's happening, and they can see who did it. Now what is Git? Well, Git is the most popular version control system out there. It was originally created by the Linux community, so mostly Linus Torvalds. But it has simple commands and is fast on any size project, which is why it's so popular. Bash is the language used to navigate the Unix-style command line. So any command that you type in is going to be a bash command. Here's some basic ones for those of you who have never used a terminal. CD uses to change directory, ls lists your files, maker to create a new folder, and touch to create a new file. So those are some useful ones that you want to remember. Does everybody have their stuff set up, or does anyone want me to wait for a little bit? All right, I'll assume we're good, and keep marching on. So, if you've never used Git before and you just installed it, then you want to do some config stuff here to add your username using the syntax here and your email. This is just giving some information for Git so that it can have record history when you go to commit and contribute to repositories. So once you've done that, we're going to start making our project. So you can go into any workspace, wherever you want on your computer, make a file using the maker command, and change into that folder using CD to start initializing your repository. Then we're going to use our very first git command and type git init. That's going to make your current folder into a Git repository. Once you've done that, we can add some files to your repository. You can use the command touch to add just a file. You can put anything in it if you want, or just leave it empty. The point is that we're making some changes, right? Normally this would be when you'd start writing your code. Git will detect the new file. If you ever want to see the status of your repository, you can use git status, and that will display basically a nice thing that will have new files or changes in red, and files that are staged for your commit in green. And it'll sort of give you a good picture of the state of your code repository. Is everybody with me? All right. So once you've added your file, we're making a commit. So the idea is we work on some code, we do all of our stuff, we test it, we debug, and then we get it to a point where we have some kind of stable version, right? We have some unit that we finished, right? Then what we want to do is we want to commit that so that if something ever happens, if we move on to the next part of our project and something breaks, we can revert back to it, or we can simply commit it into our repository so that everybody else can start using the new code. So to do that, we're going to add the new files, or the files that have changed, and you can use the command Git Add followed by your file name to go ahead and stage that for commit. Another useful trick is if you use Git Add dot, it will add everything in your current directory. So that's a nice shortcut. Once you've done that, you can commit your changes using git commit -m and then specify your commit message. If you don't do that, it will take you into whatever your default text editor is for Git and make you add a commit message and save it. So -m is typically faster. The commit message can be just about anything. I've seen all kinds of things, especially if you ever use this in a workplace. Some people are really good about logging commit messages, and some people just add whatever the heck they want for their commit message. All right, let me know if I'm going too fast, guys. So now that we've made a commit, right, we sort of have an idea of how this process works, right? You make changes, you stage them, and you commit them. Now, what happens if I want to collaborate? Well, that brings us to GitHub. So GitHub is a remote location to push and pull code, right? It's hosted on the internet. It's a place where I can put my code, that other people can see it and collaborate with me. You push and pull to keep your local repo in sync, and it's a really good way to both collaborate and have a digital resume online with all of your code. If we want to use GitHub to collaborate, well, first we got to make an account at github.com and then make a repository. So I'll pause a little bit while people do that, and if anyone has questions, feel free to raise your hand. We'll come around and see if anybody's got problems. I'm going to assume that we're all up to date here.
Also, there's a lot of pizza left, so.
That's true. Feel free to come up and get pizza at any time. So, once you have the repository, you can connect it to an existing remote. So say you want to publish whatever commit that you just made onto GitHub. Well, you make your new repository and you can connect it by using the command Git Remote add origin, and then your repo URL, which you can find if you look. You go onto your repo, you click clone or download, it'll say clone with HTTPS. You can copy this link and then insert that right for your repo URL, and that will connect it all up. If you want to connect it to an existing origin, right, if you want to make a new project locally that is a copy of one on GitHub already, then you just use git clone and then your URL, and that'll automatically pull down whatever code is existing rather than connect your existing repository to an empty one on GitHub. Once you've got this set up, you can push code from your machine, the remote, to the GitHub repo, which is the origin. And you can pull code from the origin to the remote. So this is how you basically sync code in between your stuff that you're working on and the stuff hosted online. Right? So you make all your changes, you make your commits, and when you're ready to send that up to the big repo in the sky, you push and it sends it all up. So branches, this is when things start to get crazy. Branches exist so people can work on code in parallel, right? Git uses a tree structure for branches. So you can see this picture sort of illustrates what goes on, right? We may start a repo right here at C0. We may make a couple of commits, right, C1, C2, and then my friend Brendan over here may see my project and decide he wants to help me contribute to it, right? So Brennan may make his issue 53 here. So he'll use git branch and then issue 53 to start a branch called issue 53. That'll make his commit out here, and he can work on it. He'll make another commit C5, and meanwhile I'm working in the master branch, and I add C4, and then he wants to merge his changes in because Brennan has made his cool new feature on my project, and he wants to bring it back into the main piece of code. So he'll call git merge, he'll check out into master and call git merge to merge the code in. And then if there's any conflict, so we say we both modified the same file, Git will ask you to resolve your conflicts. And so it'll give you a whole process where basically it'll outline the new stuff and old stuff right next to it. You change it, merge things, and then you make another commit when you're done and push, and it'll accept it. So that's the whole process of being able to collaborate. Just a sort of a simple example. Also, one thing I didn't mention is git branch -d removes a branch. Any questions? All right. So that's Git from a basic level. It's probably the simplest way to show it. You can get a lot more complicated with the whole history of things, but if you just want to know sort of the bare minimum of how do I contribute, how do I push, pull, how do I work on a branch, that's sort of it. So now that you've done this, maybe you want to start contributing to projects. So I'm going to use the ACM website as an example. So say you want to add yourself to the members directory of the ACM website, which is actually a great thing that we let people do. You can go to our website, right? Go to our GitHub repository, which is acmuc/acmuc.github.io. You can click the fork button, which looks like that, and that will fork the repository, and it'll basically make a copy of all that code attached to your account, and you have complete control over that code. So then what you can do is use the whole process that we outlined now to go ahead and add yourself to whatever your graduating class is in the member directory. Once you've made your changes, you add, commit, push up to GitHub, and then when you're ready to merge that back in and put it on the website, you can submit a pull request to the main ACM site, which you can do on your repository. There should be a button next to your branch that says submit a pull request. So you can click that and then follow through the prompts, and it will submit a pull request, which someone who is in charge of the ACM site, one of our fabulous webmasters or moderators, is going to be able to approve that request and merge the code into the website. And so once they do that, your new entry on the members directory will be visible for all to see. So that's it for the Git intro. Does anyone have any questions before we wrap up? Hopefully I kept it simple and easy to understand. I know in the past this has been throwing a lot of people, so I wanted to make sure we all follow along. So upcoming meetings. Stay tuned for Thursday, October 3rd, where we're going to have Christian Snyder come and give a talk about the JS compiler, not the juice or the engine, as he made sure we specified. And after that, our next meeting, which will be on October 17th, we're bringing in a guest speaker from JP Morgan, who's going to give a talk about machine learning. So stay tuned for some interesting stuff there. Other stuff around ECS is our meeting. There's the ACMW meeting, which is going to be next week, next Thursday, in ERC 427. I think they're having an info session for Microsoft. Is that right? I don't know who told me that earlier. Yeah, that's right. So that'll be something to go to. Also, IEEE is having their meeting on the 3rd at 5 p.m. in CRC 3200. So those are some other things to check out if you're interested. So that's all I've got today. Hang out, feel free to talk to people. Yes?
Can you go back to the slide about forking and
Yes.
putting yourself on the ACM
This
website?
one.
That one. Yeah.
Yes,
Thank
perfect. So thanks for coming, guys. Feel free to, stay and figure out how to do that. Talk to people, get to know the community. Have more pizza because we've got some leftovers, it seems. So, yeah. Do you have a question? No? Okay. Anything else? Yes?
Can you tell a little about Stash?
About Stash? So from what I know about Stash, what you do is say you have you have some code, right? And you're making changes, you're working on stuff, and then you realize, oh shoot, there's a bug fix, right, that I've got to make. So I've got to go switch into another branch really quickly, do this code, something like that. I can use git stash to basically save my changes, right? It'll take all of my uncommitted, unstaged stuff, stash it away. I can move into another branch, do some stuff, then go back, unstash it, right? I think the command is pop. Yeah. And that will put my changes back in so I can continue working. It's also, I think you can use it to move stuff from one branch to another. So I can stash, move into my new branch, pop, and it'll put all the new changes in there. So that can be useful if you're, hopping around places and working on multiple issues at once. Any other questions back here? Yeah.
How does rebasing work?
Rebasing?
Yeah.
So rebasing is a fun time. It's probably the most easy way for people to break everything. So the idea is, say we have like our code, right? And we want to merge things in, but we have say maybe two parallel branches that are not sort of off on the same tree. Like if I go back, you see this simple diagram up here. Say we don't have something that's simple like that, and we want to kind of fix it, right? With the rebasing, what we can do is we can almost rewrite history with basically we go in through our commit history and we merge all of the changes manually and sort of specify what the new, I guess, truth is. So say we have some different branches of code that are all messed up for whatever reason. You can rebase to kind of fix all of that.
Thank you.
That's rebasing as I understand it. Although most people, I don't think understand it. Yeah. Any other questions? Okay, perfect. I'll go back to this in case people want to try and add themselves. All right. Thanks for coming, guys.